A noise-power ratio measurement can be used to test amplifier linearity in multi-carrier satellite systems. This approach starts with a noise signal, which can be generated by a programmable noise generator, such as the UFX 7000B from Noisecom. The additive white Gaussian noise waveform is meant to replicate a wideband communication signal to stress the receiver's amplifier with simulated traffic. There are two important filtering steps for the noise signal. First, the waveform passes through a bandpass filter to fall within the amplifier's bandwidth or mimic the type of signals the amplifier will receive when in use. The band-limited noise waveform, or pedestal, now passes through a notch filter, which is designed to reject a narrow range of frequencies. In this example, there is one notch at the center of the band, which acts as an unused or quiet channel. For the NPR measurement, the notch depth is key. Right now, the power of the pedestal is much higher than the power at the notch, resulting in a higher NPR and higher quality signal. System nonlinearities can introduce intermodulation distortion, which is generated when multiple signals combine and form additional unwanted frequencies. After the signal is applied to a device under test, intermodulation distortion products will gather at the notch frequency, altering the notch depth. In a test setup, the programmable noise generator outputs the band-limited notched signal, which passes through the receiver under test. Results can be viewed on a spectrum analyzer, where users can compare the NPR of the receiver's input and output signals. Let's look at an example graph comparing the NPR in versus the NPR out. It's evident that the output signal has a significant decrease in notch depth, due to the intermodulation distortion introduced by the device under test. This lowers the NPR and indicates a reduction in system performance.